Hi guys, and welcome to another video. In this video, I'm going to show you how to translate a graph with a dilation factor. So I've got two other videos about translations and transformations of graphs, where there's one video that's talking about translating up and down or left and right, horizontally and vertically. And I've also got another video that shows you what happens when you have a negative involved in your function, where it flips the function over the y-axis or over the x-axis. Okay, so in this video I'm going to show you about dilations, and dilations I think can be the hardest out of all the different translations to be able to actually graph. Okay, so, and it's also hard to identify as well because it does get a bit confusing. Okay, so the first one of these I'm going to show you is when you multiply the right hand side by a scale factor. In this case, I'm going to call it A. Okay, so what happens when your graph looks like this, when you've got a number in the front? So for example, you can have y equals 2, fx. Okay, so where 2 is now a scale factor. Okay, you might see this, for example, in quadratics, where you've got y equals a x take 2, x take 3 or something. Like that a that you usually see with your function is going to be your scale factor, and that actually tells you whether or not your graph is wider or narrower, and that's the dilation that we're talking about, and it's parallel to the y-axis. Okay, so that's what I'm talking about here, for a little bit of an example in context. So it's it dilates parallel to the y-axis with scale factor A. And the way you can actually graph this is by multiplying the y coordinate by A. Okay, so I'm going to do an example where it's a quadratic, because that was the example that I talked about before. And it's important to note that there are two kinds of examples with quadratics. Do we remember that with a quadratic, if that A, so for example, let me just have an example here. Now, if that A was a half, what happens to our graph? Does it get wider or does it get smaller? Well, what happens is that if it's a number, if A is between 0 and 1, it becomes wider. It becomes almost like flatter, so it starts to look like this, almost, right? That's only if A is between 0 and 1. But if we know as well, if A is just bigger than 1, if A is bigger than 1, for example, like 2, 3, 4, anything like that, it becomes skinnier and skinnier and skinnier, right? So it could look like this, right? So it's important to note how those things can happen. And we do know, of course, with quadratics, if it becomes a negative, it gets flipped over the x-axis, which is exactly what you've seen before. So for example, if it was -1, we know, just like in that previous video that I showed you, it's going to flip over the y-axis, and it makes it a maximum, right? That's what we've seen before. So that's essentially what we're talking about here, like how it can change depending on what you're doing to the graph, what you're doing to your function. Okay, so I'm going to put a different color what the original might look like. So if that was my original quadratic, that was y equals fx. Okay, this one here is y a f of x, and that's if a is bigger than 1. And this is y equals a f of x. Oops, got an extra bracket in there for nothing. Let me rewrite that. And that's if it's between 0 and 1, because we remember that scale factor will actually make it wider and flatter as well. All right, so that's what happens with a number in front of a function. So just like this one here, where I've talked about this kind of like scale factor in front of a quadratic as a very common example. Now let's look at one where we replace x with ax. So if the scale factor is just being applied to just the x, okay, so not the whole function, just x. Okay, so it would look like this. It will dilate parallel, oops, not a T, parallel to the x-axis with scale factor. This is the sucker. It's actually 1 over a, the reciprocal, okay? What we've dealt with before this one here is if we've got a scale factor of a, we just multiply the coordinate by a, okay? This is different. What we're going to do is we're going to multiply the x coordinate, not the y coordinate, by 1 over a. All right, so for example, if y equals f2x, that means we're going to multiply our x coordinates by by 1 over a. Okay, so when we do these ones here, for example, in that first example, with this green one here, we took a coordinate. If this was, for example, 1, we multiplied the coordinate, the y coordinate, by the a. So if it was 2, for example, we'd make it 1, 2, and we'd rewrite it. So 1, 2 would be up here, right? And so forth, so forth. And we'd keep going. This was the next one. So we had, 2, 3, for example. I might say, well, I'm going to multiply that 3 by 2, which is 6. I'm going to have 2, 6, and that will be my next kind of coordinate, and we'd plot it that way, if that makes sense. So for this example, instead of multiplying and it gets bigger and bigger, it's going to actually change it totally in a totally different way. So let's see if we can graph it and show you what I mean. So I'm going to show you a situation where it's a cubic. So if my graph looked like that. So if the cubic, for example, so we know that y equals ax cubed plus bx squared plus cx plus d. Now this a, if it's greater than 1, it's going to actually make it narrower, similar to quadratics. It's going to make it narrower. So we would make it like this. It's going to like push it inwards. And then it's going to, if we have a number that's bigger, or in between 0 and 1, it's going to make it wider. So it's going to make it like that, where our original is going to get bigger, like that. Okay, so it's very similar to this first example, but it's more like it's been stretched over the over the x-axis. It's been stretched out. Okay, so which is slightly different to what's happening in our first example in this one here. Okay, and the way you do that, you'd get a point on your original. Okay, so if this is, for example, -1, 1, you would multiply your x coordinate by by 1 over a. So for example, if it was 2, you'd multiply it by 1 over 2, which it would be a half. So it'd be a half. So instead of being here, where this is 1, it'll be at a half, which is here. Okay, so that's what happens to it. It actually changes it. Okay, so what I'm going to do in the next video is going to show you some applications of these transformations. So I've gone through a whole bunch of different transformations, and I've gone through just very generic sketches of it, but let's see if we can actually apply those with coordinates and everything to help us visualize what these transformations look like.